Hey everyone, Mr. Skelton here. Today we are starting Unit 5, our 5th unit of the school year, which is hard to believe. Excuse me. And in this unit, you're going to see a lot of triangles again, but in this unit we're not proving them congruent. We're going to show that they're similar to each other, and you're going to learn about that word similar or similarity in our next lesson, in lessons 2 and 3 and so on and so forth. So today we're going to kind of introduce some of the basic algebra that you need to know to move forward, and a lot of this will be review for you, which I hope is good, and I hopefully you can recall some of this stuff. So let's just jump right into it. Here's our learning targets. 1, we want to understand the difference between a ratio and a proportion. We want to use properties of proportions to rearrange some proportions, and we want to be able to set up and solve proportions. So you probably recognize some words there. You may not remember them, but that's okay. That's why we're going to practice and go through this lesson. So let's jump into it. Another name for a ratio. A ratio is just a fancy word for a fraction. Okay? Literally, that's what a fraction is, just a ratio. There's a technical definition. It's a comparison. A ratio is a comparison of two items, right? Like miles per hour, inches and miles, whatever. You're comparing two things. So if a ratio is just a fancy word for a fraction, a proportion is a statement of two ratios that are equal. This right here is an example. If I move this up, this right here is an example of a proportion. This is a proportion. A proportion is two equal ratios. Two equal ratios. Okay, two equal fractions. And I'm going to go through two. There's like 4 of them in terms of properties that we can talk about. We're just going to use 2 of them in this lesson, so we'll jump right into it. Cross multiplying is how you solve proportions. How you solve proportions. That's the method. Okay, and most of you have probably heard of cross multiplying before. So if you cross multiply, it kind of makes like an X or a cross. So A times D equals B times C. And that's using cross multiplication to solve proportions. Okay. Now, what I'm going to show you here is just a rearrangement of this proportion to still get what we want. And so I'm just going to give you an example of B over A. So all I'm doing is flipping this B with this A. If I go B over A, what do you think the right side has to be? It has to be D over C. So whatever you do here, if I flipped A and B, I'd flip B and C. That's the reflexive property. Okay? And so, or excuse me, not reflexive, duh. Thinking about Unit 4. How about reciprocal? That sounds better, right? Reciprocal, because we're flipping it, right? The reciprocal is when you flip something. Sorry, reflexive, I'm so used to Unit 4 here. So down at the bottom are a couple of questions, just getting you used to working with these proportions and how you can adjust them. So here's the problem. If A over 4 equals 12 over B, then ... AB. So how are they getting AB? Well, they're going A times B on the diagonal. I have no idea why it does this, sorry. A times B on the diagonal. So then we would have 4 times 12. If you go A times B, you'd go 4 times 12, or 12 times 4, doesn't matter. Okay? Second one, B over 12. B over 12 would equal what? If I go B over 12, then I'd have to go 4 over A. So 4 over A. Okay? And then if I go A over 12, so look, A over 12, if I go A over 12, I need to go 4 over B. Now I want to show you something here with all of these. 4 times 12, if you take out your calculator, some of you may not know this by already, you get on number 1, A times B equals 48. Take a look at number 2. If we were to cross multiply here, b times a would be ab. What's 12 times 4? 48. Look at number 3. What's a times b? A times b is a times b. 12 times 4 is 48. So using some properties of proportions and rearranging, you just have to make sure that you're consistent. If you go a times b, 12 times 4, if you use the reciprocal, make sure you reciprocate both sides. But when you finally have them set up, you should all get the same thing. Okay? Let's flip it over on the back side. On the back side, you're going to notice just some basic Algebra 1 problems, probably recognized from last year. It says solve each of the proportions for the variable. And so what I'm going to have you do is actually just hit pause, and I'd like you to try all 3. Number 2 and number 3 are kind of a doozy, but I want you to at least see if you can get them set up, and then you can hit play again, and I'll show you how to solve these, okay? Give them a try. All right, we're back here. We're going to set up and solve these. So let's look at number 1. We're cross multiplying. Some students will, you may have learned back in Algebra 1 or maybe your middle school, the butterfly method. Some of you may use the butterfly method where it kind of looks like a butterfly. I'm timesing these two, so 8 times y is 8y, and then I get 4 times y plus 3. This is important that you put the y plus 3 in parentheses. This 4 needs to get multiplied by the y and the 3. We call this a quantity. Okay, y plus 3 is a quantity. Now, sometimes students will ask, Mr. Skelton, does it matter which side the 8y is on versus the 4 times y plus 3? It does not matter. You could have easily switched these around. Okay, so let's solve this. 8y is 8y. We got to distribute, so 4y plus 12 minus the 4y from both sides. 4y equals 12. Divide by 4, and y should equal 3. Okay. Let's look over at number 2. So we're going to challenge you a little bit with some of your algebra skills here. If you take a look at this one, 6 times 3 and then x times 2x. 6 times 3 is 18. 2x and x. A lot of kids are going to put 3x down, but you're multiplying. So really, 2 times a 1, there's really a 1 there. 2 times 1 is 2. What's x times x? X squared, right? So when I divide by 2, I get 9 equals x squared. And how do you solve for something that's x squared? What's the opposite operation of something squared? Something square rooted. And so we get plus or minus 3. Remember that x can be plus or minus 3 here, because you could plug in a negative 3 for x squared. Negative 3 times negative 3 is still positive 9. Okay? And let's look at the last one here, number 3. This is a really tough one. Most of you are going to get 2 times 10, which is 20. And then you have this, which is 2 quantities. The quantity of x minus 2 times the quantity of x plus 3. So you're going to have to do your FOIL. I don't teach the FOIL method. When I taught Algebra 1, I taught distributing twice. So this is what it looks like when you distribute twice. I'll use colors here. I'll take this x, circle it in blue, and I'm going to distribute that to the x and to the positive 3. So I'm going to get 20 equals x times x is x squared. X times 3 is 3x. Okay? And then I'll use my black pen here. Oops. I'm going to take this negative 2. Notice how I include the sign, the minus 2. That's a negative 2, and I'm going to distribute times the x and the 3. That's why I call it distributing twice. So negative 2 times x is negative 2x. Negative 2 times a positive 3 is a minus 6. So I get 20 equals x squared. I have like terms right there. 3x minus 2x is just x minus 6. Now, solving this is challenging. Not a lot of students are going to remember this from their Algebra 1 days. Okay, I'm going to subtract 20. So I'm going to get x squared plus x minus 26. Is that right? I believe, unless I made a mistake. Okay. Now, in terms of solving this, okay, we have to come up with 2 numbers, okay, that multiply together that give you negative 26. Add them together, you get 1, which I don't see any, and I'm just going to double check my math here, but we should be in a situation where we should try to factor this. What if I write down the factors of 26? 1 times 26, right? 2 times 13. I don't think 3 goes into 26, okay? 26 divided by 4, this doesn't work. 26 divided by 5, obviously, divided by 6, divided by 7, divided by 8, divided by 9, none of those work. None of these are going to give you 1, so how do you solve this? This is a tough problem. The directions do say to solve for x, so we need to use our good friend, the quadratic equation. This is a quadratic, okay, or the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Oh boy, here we go. Your a value is a 1, your b value is a 1, and your c value is negative 26. So you end up getting this. Negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 26 all over 2. So x equals negative 1 plus or minus. Inside I have 1 squared, which is 1. 4 times 26 is 104, so plus 104 all over 2. So x equals negative 1 plus or minus the square root of 105 over 2. Now I don't think 105 breaks down. If you were to make a factor tree, I don't think you're going to get anything out of that. I'm just trying a couple things here real quick. 105 divided by 16, no, 105 divided by 6. So I'm going to leave this as my answer right there. Now that's kind of nasty, okay? But that's how you would do that problem there, okay? So let's go on to the very last question. This is something that's very useful, very much applicable back in the day before GPS and smartphones and all that good stuff. Probably don't remember looking at an atlas and knowing that on a map you'd have a scale of 3 inches is 70 miles and trying to measure things out. So it says to set up a proportion. On a certain map, a scale is 3 inches is 70 miles. Okay? If the distance from Fort Wayne to Indianapolis is 110 miles, how far is that on a map? So basically it's saying how many inches is it on a map. So notice I have inches over miles. I want to make sure that I go inches over miles. I want to keep it the same whenever we do proportions. Okay, so it's 110 miles, so I'll put that there. I don't know how many inches it is. That's what I'm trying to find. So that's how you would set this up. So you'd cross multiply. 70 times x. So if you're doing your butterfly method here, 70 times x is 70x. 3 times 110 is 330. And you would divide that by 70. Divide that by 70. And we'll just round it to the nearest tenth, so it's going to be 4.7 inches. Okay? So I know I gave you some tough problems here, especially the quadratic formula one. Remember that anything x squared is always a quadratic, and that means you can always use the quadratic formula. That's the quad formula, all right, to get an answer for x. So I think we should be in good shape moving forward. I hope that you find this to be hopefully not too difficult for you, but a good review. All right, see you back in class, and talk to you later.